Namaste. Welcome to this channel, Dr.ARM's Chemistry. We were discussing the chemistry of 3D metal elements or 3D elements. So we have seen the various points under this title in previous lectures, and today we are going to see or discuss about the Kepart model. We have seen that Werner's theory, or Werner we can say, is considered as father of coordination chemistry. So this explains the volume of the credit that is given to his research work or contribution to the coordination chemistry. So he has given a lot of fundamental things or concepts in which the future of this theory is also based, or the foundations, in other words you can say the foundations of Werner's theory or Werner's concept are very important, which are suitable and not replaceable even after considering or arising new technical methods for investigation of structure. And such base or foundation of Werner was so correct that number of formulation of D block complexes were carried out. After many years of this work, it was assumed that the metal ion in the given oxidation state has a fixed value of coordination number and geometry. So this was assumed after Werner's foundation. Later on, the VSEPR theory, that is VSEPR model, we can see. So this is also discussed in previous topics, so you can refer in that topics. According to this VSEPR model, it was considered that the P block complex, the P block elements gives their complex compounds which are having varying arrangements of other, means atom at the center and other atoms around this. So this arrangement of other, we can say in other words a ligand for in order to understand. For example, if we consider the BF3, SiCl4, PCl5 and so on. So in this case you will find that the central atom, boron, silicon, carbon, phosphorus, etc. So these are showing varying electronic structures, and according to VSEPR model, the structures are having different arrangements or geometries. So these geometries were considered according to VSEPR model, in which it says that the boron or the central atoms are showing varying electronic structures. It means VSEPR model gives a stress on the electronic configuration of P block elements that is varying while we are moving from left to right in a period. And it predicts that the varying electronic structure is responsible to the varying geometrical arrangements of atoms around the central atom. So this is VSEPR model. So this is observed in P block elements like this. But if we consider the D block elements, then we find that if we consider few examples of these D block elements. So in case of D block elements, we can consider the arrangements. Say D2 configuration is observed in case of V, vanadium H2O6 3 plus. If we go to D4 configuration, the example is Mn H2O6 3 plus. Again, if we consider D6 configuration example, that is CO H2O6 3 plus. Then if we consider the example of D8 complex, that is Ni H2O6 2 plus. Then the 10th configuration shows zinc H2O6 so here you will find that this D2, D4, D6, D10, D8 and D2 shows that as we move from left to right in the 3D period, third period, the D block element shows increasing nuclear charge and atomic number, means the electronic configuration of these vanadium, Mn, CO, Ni, etc. is changing as we move from left to right as shown in these complexes. And according to VSEPR model, we are expecting that these arrangements of ligands around the central atom, H2 around Mn, H2 around cobalt, nickel, zinc, etc., should vary. Means they are not expected to have same electronic arrangement of these ligands. So according to VSEPR model, these arrangements are expected to change or vary with electronic configuration, but this is not happening. All these structures are octahedral, means same, even though the electronic configuration changes. So this is the failure of VSEPR model. Kepart model shows that the metal ion shows that the metal ion has, the complex has metal ion at the center. Metal ion is at the center, and ligands are occupying the specific positions around this central metal ion. So we can show that these arrangements are like this. So here, if we consider the charge on this complex is N plus, then we understand that in these structures, the metal ion is at the center and ligands are freely moving around the sphere of the metal ion. So the ligands are considered to repel each other. As a result, the arrangements may vary. So the ligands are considered to repel each other. So here there is only some similarity, only few similarity, that ligands are repelling from each other, so that they are occupying a fixed position of ligands. Means the distance between the ligands is controlled by the repulsive forces existing between the ligands. So this is the similarity between the Kepart model and VSEPR model. So according to the ionic effects, we say that metal ion is at the center and the negative charges are surrounding it like this. So this is showing electronic effects. So Kepart model ignores the non-bonding electrons. Kepart model ignores the non-bonding electrons. So the ligands may have additional non-bonding electrons and they may also create some electronic effects. So these are ignored in Kepart model. Thus, Kepart model considered that the coordination geometry of such complexes does not depend upon electronic configuration of the central metal atom that is in the ground state, and therefore the geometry of the resulting complex may not vary as expected according to VSEPR model. Hence, we can show that the complexes such as ML, N, then ML, N plus M, and ML, N minus M, they are having different electronic structures, but their arrangements may be same. But their arrangements of ligands means the coordination geometry is same, or it may be same. So by ignoring the lone pair effects, the Kepart model proposed the geometrical structures or geometries to the complexes of the elements as follows. So if we see here, we can show this coordination number and geometries. Then we find that when coordination number of the metal ion is 2, the geometry is linear. When coordination number of the metal ion is 3, the geometry is trigonal, planar. When geometry is 4, when coordination number is 4, the geometry is tetrahedral. Geometry is tetrahedral. When coordination number is 5, the geometry is trigonal bipyramidal. And square based pyramidal so there are two options. Then sixth, then coordination number is 6. The geometry is octahedral. So, according to Kepart, these possibilities of geometry is like this. Then, these we have already discussed or given variety of geometries depending upon coordination number in previous lectures in a tabular form. Some of the arrangements which are given in that tabular form are same as given by Kepart Model. The coordination number, the coordination sphere of a metal ion, the coordination sphere of a metal ion in complex Cu, Cn, Cu, Cn. Like this. So it can have a structure like this. So it has 2 minus charge. So here this complex is predicted by Kepart model to be trigonal, pyramidal, trigonal planar. So this complex has structure trigonal planar. It is also found, means this structure is also proved or supported by experimental facts. So even after this, yes, similar to this structure, similar to this, many other complexes are there which cannot obey or which cannot follow the Kepart directions or Kepart model. So Kepart model also is found to be held to explain variety of facts. For example, Kepart model fails. Failure of this Kepart model. It shows that it shows that in case of a porphyrin ring, there are 4 nitrogens which are standing like this. 4 nitrogens are, means I am not showing all these structures, complete structure. So the 4 nitrogens of porphyrin ring are present in a square planar form. So this is not explained by the Kepart model. Then second is tripodal ligands. Second is tripodal ligands. Tripodal ligands. So we can show the example like, say this is X. So this is a tripodal ligand. Here X can be, here this X is, this X is CH3, CNE, nitrogen, phosphorus, etc. So this is, or in other words we can see here X is equal to, in order to avoid confusion we will say X is equal to C. This methyl group is attached to carbon. In addition to, there are other trivalent elements like nitrogen, phosphorus, etc. So they can be used to obtain here the tripodal ligand. So the tripodal ligands have limited flexibility according to this, and in which the donor atoms are not necessarily free. Means the donor atoms like this are not necessarily free to adopt the desired shape or predicted shape or positions by Kepart. So Kepart, according to Kepart's model, the expected position is not taken by this X because these are not, this is not flexible. The position is fixed. So this is the second. Then macrocyclic ligands are less flexible. So as we have seen earlier, the porphyrin ring structure, or there are number of such ligands, for example EDTA or DMG, dimethyl glyoxine, etc. So they are not so flexible than the open chain structure. The open chain structure, as we have seen in the CN, C triple bond N, in case of CuCl3 2 minus complex. So this is about the Kepart model. Means Kepart model is successful to certain limit, but it has also considerable number of limitations. So with this we will stop our discussion and we will continue our topic with the coordination number and geometries in solid state in the next lecture. So till then, goodbye, see you next time. Please subscribe to this channel and press like button and bell icon. So thank you very much for watching this video.